Hi, welcome. This video is about how to solve a system of equations using a process called row reduction of the matrix. And our goal when we're doing that is to get a matrix that looks like what's called the identity matrix, where it's 1, 0, 0, sorry, right there, 1, 0, 0, 1 on the left. And then on the right, you'd have the values for x and y, which are your solutions. So if you get the matrix to look like that, then you have your solution of x and y. And um, you can switch rows. You can take the top row, switch it for the bottom row. You can multiply a row by a number. You can divide a row by a number. For that matter, you could multiply it by a fraction if necessary. And then you could also multiply a row and then at the same time add it to the other row to get a new row as a result. And so all of those are things that we're going to do, and you'll see that in this example. But the first thing we want to do here is to convert it into an augmented matrix. And so we have 1, -4, -2, where the 1 is the coefficient of that x. And then we have -2, 1, and -3. And that's our augmented matrix. And so here, kind of nice that we already have a 1 here in this place right here that we want it to be. There's already a 1 there, and so that's nice. We're going to leave that there. But I think what would make this -2 0 if I added it to 2? And so if I multiply 1 by 2, if I take row 1, 2 times row 1, like 1 times 2 gives me 2, and -4 times 2 gives me -8, and -2 times 2 gives me -4. And so I'm taking all of the values on the top, multiplying them by 2, and then I'm going to move that down just a little bit. 2 times row 1. Again, this is row 1, the top, and this is row 2. We're taking 2 times row 1, and we're going to add it to row 2, and that's going to become our new row 2. Just double check here. 2 times row 1. 2 times 1, 2. 2 times -2, -8. And -2 times -2 would be -4. And so now just add those. -2 plus 2. Well, my top row stays the same. Sorry. There's 1, -4, -2. We're just going to keep that one the same, even though we're using it to cancel out some things on the bottom. -2 plus 2, 0. That's the 0 that we wanted. -8 plus 1 would be -7. And then -3 plus -4 is also -7. Now, if you've watched some other videos, you already know this, but we kind of want to work in this direction. We want to start up here and get that to be a 1, and then move down here and get that to be a 0, and then go over here and get this to be a 1, and then finally move up here and get that a 0. And if you do that, that is the best way for this to work. So I've got a 1 and I've got a 0. Now I need to make that -7 1. So I'm going to take the top row, stay the same, 1, -4, -2. But to get the bottom row to equal 0, 1, I'm going to divide it all through by -7. So I'm going to take row 2, write this over a little bit, row 2, divide by -7, and that will give me my new row 2. So 0 divided by -7 is still 0. -7 divided by -7 is 1. And then over here, -7 divided by -7 is also still 1. So that's my new row 2. Now, what would I multiply by 1? Because I want to get this -4 to be 0. What would I multiply by 1 to get that -4? And I think 4, because the opposite of -4 is +4. So I'm just going to think real quick. 0 times 4 is 0. 1 times 4 is 4. And 1 over here, 1 times 4, also 4. And what I'm doing, just so I can keep track and let your teacher know, to get my new row 1, I'm taking row 2 and multiplying it by 4. So 4 times row 2. I'm adding it to row 1, and that will give me my new row 1. So 1 plus 0, 1. Negative 4 plus 4, 0. And negative 2 plus 4, 2. And my bottom, I'm going to keep it the same, 0, 1, 1. And now we have this, which was our goal. There's our augmented matrix, the same as what we have down here. 1 starts with the 1, then goes 0, then 0, then 1. And then this value right here, x and y, that's 2 and 1. And so our solution is the point 2, comma 1. That's 2 in x and 1 in y. And that would be our solution. And you can verify that, prove it by putting in 2 for x and then 1 for y, and showing that in this case that would be equal to negative 2. And if I put 2 here for x and 1 here for y and evaluate, that should be equal to negative 3. And I'll leave that check to you for you to do.